Hey, it's Mrs. Moret with today's assignment, Unit 6, Lesson 2, page 17, numbers 1 through 6. So we did a whole bunch of trig ratios in class today. So let's look at number 1. We have our triangle here. We know all of the sides. And so we're looking at which of these are true statements. So the sine of angle A, well, here's angle A. And opposite angle A is the side that's marked 6. And the hypotenuse is 10. So I think this is a true statement because remember that the sine of an angle is equal to the opposite leg over the hypotenuse. The cosine is equal to the adjacent leg over the hypotenuse. And the tangent is equal to the opposite leg over the adjacent leg. So for the angle A, opposite over hypotenuse is 6/10. So for sure, it's not the cosine of A. The cosine of A would be 8/10. All right. So this is the true statement there. Number 2. So number 2, this is kind of like what we were trying to get to at the very end of class. Understanding that when this has a length of 1, if this triangle were on a circle, then the coordinates of this point right here, the x value would be the cosine of the angle, and the y value would be the sine of the angle. And so the coordinates there tell us, to get from this direction, it's the length of the cosine of theta. And in this direction, it's the length of the sine of theta. And so segment AB is this leg down here. It's the cosine of angle A, which has a measurement of theta. And then BC is this segment here. It's the sine of angle A, which has a measurement of theta. All right. Okay, number 3. These triangles are similar. So since they're similar triangles, I know like that each segment or side on this triangle is going to be 1/13 of the larger triangle because the hypotenuse is 13 in that triangle and 1 in this triangle. So we actually use the same exact size triangle in class today. So the length of segment DE and EF. So DE is equal to 1/13 of 12. 1/13 of 12 is 12/13. So in the little triangle, it has a side length of 12/13. And then EF corresponds to this one over here. So EF is 1/13 of 5, which is 5/13. So this side is 5/13. Okay, explain why the length of segment DE is the cosine of D, and the length of segment EF is the sine of D. Well, the reason why is because the hypotenuse is 1. So for this angle here, D, the cosine of D is equal to the adjacent side, 12/13 divided by 1. So when you divide 12/13 by 1, it's just 12/13. And the same, which is the length of the side. And then the same happens for the sine of angle D. The the sine of angle D is going to be the opposite, 5/13, divided by 1. And when you divide by 1, you just get 5/13. Okay? All right, number 4. Here is a triangle. Find the cosine of A, the sine of A, and the tangent of A. Well, before we can do that, we have to figure out the hypotenuse because cosine and sine both require the hypotenuse. However, we can find the tangent of angle A. It's equal to the opposite leg divided by the adjacent leg. It's 2/6. So we don't need the hypotenuse for tangent, but we do need it for cosine and sine. So the hypotenuse of this triangle, I'm going to call it c squared, is equal to 6 squared plus 2 squared. That's 36 plus 4, and 36 plus 4 is 40. So c is equal to the square root of 40. We can just leave it like that because 40 is not a perfect square, so may as well just label this the square root of 40. Okay, so the cosine and then the sine. So cosine of A is equal to the opposite side, 2, divided by the hypotenuse, the square root of 40. And the sine of A is equal to the I messed that up. I said cosine was opposite. That's not cosine, that's sine. This is cosine. We'll just do that. So the cosine of A is equal to the adjacent, which is 6 over 40. So sorry about that. Okay, so the sine opposite over hypotenuse, 2 over the square root of 40, and cosine adjacent over hypotenuse, 6 over the square root of 40. We're almost done. Number 5, sketch and label a right triangle ABC such that the tangent of A is equal to 2. Okay, so I'm going to have the right angle be on the x-axis, and there's 2 ways I can do this. So I'm going to have angle A be at the origin, and then if I want the tangent to equal 2, and I know that tangent is the opposite leg divided by the adjacent leg, I could make the adjacent leg a 1, which is that length, and the opposite leg a 2, and then connect it there. So if this is 1 and this is 2 and this is angle A, then the tangent of A is equal to 2 over 1, which is 2. I could have made other lengths, maybe a different one. It just has to equal 2 when you divide. So maybe I could say, well, probably not yellow. I'm looking for a different marker. Here we go. What about this one? If this is 1.5 and this is 3. There's another one where this would be 1.5 and this would be 3, and still using angle A. So a different option looks like that. So that just when you divide the opposite legs, you get a value of 2. So there's another one, at least one more that I can think of that would fit on this grid, but there's 2 examples for you. Okay, finally number 6. The point 1, 4 lies on a circle with center at 0, 0. Name at least one point in each quadrant that lies on the circle. Okay, I'm going to draw this. Do much better. I'm going to actually draw something out. We'll see how well it turns out. So far, it's not looking great, but it's okay. So let's just pretend that that is a circle, not a flat tire. Definitely looks more like a flat tire, but that's okay. All right, so the point 1, 4 lies on the circle. So I'm just going to guesstimate and say it's right here. This is 1, 4, and it's on the circle. And I knew to put it there because 1 and 4 are both positive. And so we've done a lot of this. We need to come up with 4 answers. So if we reflect it over the x-axis, we get 1, -4. If we reflect it over the y-axis, we get -1, 4. And if we reflect this one over the x-axis, we get -1, -4. So there's 3 of the additional points, but we need one more. And this came up in class today. There was like a student in each class that knew this. Going back to this original point that was given, if we switch the x and y values, we would still have whatever this radius is. If r squared is equal to 1 squared plus 4 squared, if we switch the 1 and the 4 around, that would still be true. So that gives us, I'm going to estimate it to be there, right here in quadrant 1, 4, 1. Okay, so we've got one additional point in each of the quadrants now. All right, so that is the end of the assignment. I hope the video was helpful.